Hi, this short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. We are looking at particles and waves, and we are looking at wave-particle duality. Here's a question we might expect to see in the exam paper 1. A photon of energy, 5.6 times 10 to the negative 19 joules, strikes a metal bar, and as a result, an electron is emitted. The maximum speed of the emitted particle is 6.4 times 10 to the 5 meters per second. What is the work function of the metal? So what's our approach? Well, we need to read the question closely and pick out the things we're being asked about. We can see there's a photon energy. We know it's striking a metal bar and electrons flying out, and we know the speed of the electron particle coming out. And we need to find the work function of the metal. Any options that are obvious that we can ignore? Not really. Recall that this is in the wave-particle duality part of the course, and always take time to reread the question and avoid overcomplicating. If you find yourself lost in what's going on, take time, read it again, and in this instance you might want to draw a picture of what's happening. That might help. So from the teachings, what is happening here? Well, we know that a particle has been emitted. We know that particle is an electron, and we know that there's a speed involved. So we might want to check the data sheets to see what relevant information there is there. We know the data sheets will give us the mass of an electron. That might be useful. And we know there's an equation in those data sheets, E equals a half mv squared. Energy equals a half times the mass of a particle or an object times its speed squared. So that could be useful to us. We know that that's been emitted from a piece of metal, and we know that we're looking for the work function being the energy, minimum energy required from an incident photon to release an electron from that metal. So there we have our inbound photon striking the metal and electrons being emitted, and we have discussed that energy equation, the kinetic energy equation. So the energy striking the metal bar requires a certain amount of energy, the work function, before it will release an electron, and that released electron will have some residual energy left over, and that will be the incident energy subtracted by the work function, and it's this one that we're trying to find. So what do we know? Well, we know the mass of an electron. We know the speed because it was given to us in the question. So therefore we know we can work out this. And if we know what this is, well, then we know what this is. But we're also told what the photon's energy was. And so if we know the photon's energy and we know this, then it should just be a simple subtraction to figure out the work function of the metal bar. And that's exactly what we have to do. So there is a few steps to do here, but we should get to the answer. So we can go ahead and work out the answer, being very careful that we do all the correct steps and we have everything in the right units. So we know that E, the energy of the electron, which is the incident energy of the photon minus the work function of the metal bar, is equal to a half mv squared. And we know that the electron mass is in our data sheet, and we were given the speed. We just need to remember to square that speed. We were also given already the incident energy. Let me just do that. That was given to us here, photon of energy 5.6 times 10 to the 19. So we know what that is. So we now have a value both for the combined and the incident. So we can go ahead and work out the value of the difference, which gives us the work function of the metal. And we just want to make sure that we've got the right units all the way through. That, of course, provides us with our answer, which is answer C. So there is a few steps going on there. Some of the key things to watch out for in this question: keeping an eye on those powers of 10 that are being used. There are a lot of them. Not missing out the squaring of the speed. I think that's another really important step. And then making sure you've got the subtraction in the correct order. Always take a look at the units being used, because if you're not sure what kind of variable is being described, sometimes the units will help you out. So we have a few more examples here, as per usual. Answers on the Hi page, hy.page/physics FYSX. Give those a go. And thanks very much for watching.